So in this video we're going to take you through the making of an electronic kit, specifically the MERG Servo 4 driver kit, which is available from the MERG kit locker. And this is a previously made one, and we can demonstrate how it operates. So here we have the completed kit with a power supply and some switches for operating the servo motors, and they in turn operate the points. And we can see them operating. We're now going to talk about the tools that you will require. I tend to use a temperature controlled soldering iron set to about 370 degrees centigrade, and you need to wet the sponge, not thoroughly soaking but just slightly damp. Turn the sponge over, do the other side, and then when the soldering iron is up to temperature you should hear it hissing as you're wiping off the excess solder. The other tools you will need are a pair of side cutters, a pair of pliers, some tweezers. These are stainless steel anti-magnetic, which are very useful, a scalpel or a small knife, the MERG bending jig, which we'll describe later, some solder, and one thing I find very useful, especially when you are making a kit on the kitchen table, is a small dustbin for putting the offcuts in. Now when it comes to solder, we recommend you do not use lead-free solder because it's very hard to see if you've got a bad joint with lead-free solder, and there are different thicknesses of solder. This is the one that I tend to use for kits, and we can see here a number of different sizes of solder. So this particular one is what is known as 22 SWG. And the other thing we will need is a fine tip for the soldering iron. Not the big one that tends to be supplied, but a fine tip which makes life a lot easier. Some other things worth considering are some form of headband magnifier like this. I find this particularly useful because you can push it up and you can see in the distance, or bring it down and you can see close up. It may also be worth considering some form of wire strippers. These are ones that I particularly like because you can adjust the amount of insulation that is stripped off by moving this part here. And some people like to use a small stand with a magnifying glass and LED lights, and also some crocodile clips for holding the printed circuit board. When we unpack the kit, we find there's a set of building instructions. There's the printed circuit board, which has a silkscreen printing on one side to help show you where the components go. We have a card with various resistors, diodes and so on taped to the card, all showing their value and the number, which helps work out where they're going to go on the printed circuit board. We have the IC holder and the IC or PIC, which is the brains of the device, and we have a bag containing the other components. Before we begin assembly, we need to check the kit contents against the table on the building instructions to make sure we have everything. In order to start assembling the kit, you need to follow the instructions, and it's a good idea to read through them all first before you start. And this will take you through adding the components, normally the smallest components first. And normally it would be something like the wire links, if there were any, or the resistors. In this kit we add the resistors first, as it says in the beginning of the instructions, and it's a good idea to tick off what you've done as you go along. Now, as it says in the instructions, the resistors are colour-coded and you have to be careful whether it's a 3-band or a 4-band resistor. There is a table in the instructions which show the difference between the resistors with the blue background and a beige background. So for example, we have on a 3-band colour we will have a brown, black, red, and on a 4-band we will have a brown, black, black, brown. Sometimes one particular colour will be inserted in the kit depending on what the kit packer has available. We now have to take the resistors away from the card, and my suggestion is only to do a few resistors at a time, maybe the ones of the same value. So we're going to put one cut here and one cut here, and we're going to lift off the 10K resistors. We pull them away from the sticky tape. So now we have to take the sticky tape off. And we pull off the end pieces here, and we now have the 3 resistors ready to insert into the printed circuit board. Checking with the card, the first resistor we're going to fit is R1, and we're going to use the bending jig in order to get the spacing. If we put the bending jig over the printed circuit board, we can see that the holes are too far apart on the first notch, but around about right on the second notch. So we can use this for bending the legs of the resistor. So we place the resistor on the bending jig and then bend down both legs, and then that should be a perfect fit in the printed circuit board. First of all, we look on the printed circuit board for R1, and we fit that like that. Then we need to fit R2, and finally, in this case, R7, which is near the top. Now the resistors can go in either way round, they're not polarised, but it's sometimes a good idea to always have the colour bands in the same orientation for all the vertical and for all the horizontal ones, which makes it much easier for fault finding later on. And the next thing, we turn the board over. Now we were lucky when we turned it over that nothing fell out. If that tends to happen, one trick you can use is a couple of spring clamps and a piece of hardboard, and then you can place the hardboard over the components, hold them in place with the spring clamps, and now they stay in position. Now instead of using the spring clamps, we could just bend the wires slightly, which will stop the components falling out. And that means we can lay the whole board flat on the workbench. You don't want to bend them too much, just slightly to stop them falling out. And the next thing to consider is whether to cut the wires close to the printed circuit board or not. If you're doing a complicated circuit and you're fairly new to this, you might want to keep them long to make it easier to find where they are. On the other hand, you will find it takes a little bit longer to solder. So it's a good idea then to cut the leads close to the printed circuit board. Now when you cut them, you don't want to hold the side cutters close to the board. You want to have it at a slight angle, which leaves a small amount protruding. Now the idea here is to heat the lead and the part of the printed circuit board and then apply the solder, and the solder we use does not need any extra flux because it has flux inside it. So we put the soldering iron on the lead and the printed circuit board, and if you're a beginner it's a good idea to do something like count to 3 and then apply the solder. Then we take the soldering iron and the solder away without moving anything. So let's try that. So we put it there, 1, 2, 3, and apply the solder. Make sure it goes all the way round and then leave it to cool. Now we've soldered all 3 of those resistors in, we need to check that in each case we have a nice shiny volcano without any holes. If there's a hole appearing on the side of the component lead, we need to reapply the soldering iron until the solder goes all the way around the lead. So having fitted all the resistors, the next phase, according to the instructions, is to fit the diodes. There are 2 different types of diodes, and we're going to fit D1 first. D1 fits in this position, and you can just see a band on the end of the printed circuit board, and that must correspond to the band on the diode itself. And we're going to use the bending jig again. This time it will be the first notch, and we will bend the diode, insert it in the printed circuit board and solder it into position. The next component is the dual inline socket, which is what the PIC is inserted into after we've done the initial testing. So that's this component here. Now when we insert the DIL socket, we have to ensure that the notch on the socket, shown at the end here, is in the same place as the notch on the printed circuit board, shown here. Having inserted the socket and turned the board upside down, we find the board is not lying completely flat. So we can prop up one side with whatever comes to hand, and then we can start doing the soldering, but we'll only do 2 diagonally opposite corners. So we'll solder one end first, and then the opposite corner, now we turn it over and we check that it's nice and flat to the printed circuit board. If it isn't, we can hold it down and reapply the solder to the relevant position. By pushing it down, it should then snap into position. Then we finish soldering the rest in. The next component to fit is the 8-pin resnet, so we need to find that amongst all the components and fit that in the printed circuit board. This 8-pin resnet can be fitted either way round. What we're going to do is to solder just one end first, and then we're going to turn it over to make sure it's upright. Now if it's not upright, we can now apply the soldering iron to the one end that we've soldered by at the same time gently applying a finger to bring it into the upright position. Now we fit the 5-pin resnet package, and this one has to be fitted the right way round. There's a dot on the resnet at one end, and that has to be fitted into the little square on the PCB. Now we fit the bridge rectifier, observing the markings on the component itself. The 2 squiggly lines are for the AC input and the plus and minus are for the DC output, and these must correspond with the markings on the printed circuit board. Now we locate the 18-pin PCB header strip and cut this according to the instructions, first into a 2-pin header with a pair of side cutters, and then into a series of 3-pin headers. So we fit them into the printed circuit board, and instead of using the hardboard and the spring clamps, I'm going to use a piece of foam similar to that on which the PIC came. And the idea of that is just to press down on top of the pins to keep them upright while I solder them in place. If you use the spring clamps and the hardboard, then the solder will melt the plastic and the pins will move through. As before, we're going to solder just one end of each component, so we can then check that they're lying flat and upright. And as you can see, they're not exactly upright, so we can apply a finger or a thumb, making sure we don't put it on the one that we've soldered, and then just apply the soldering iron, and then it should snap into position and they should all end up nice and flat and upright. And now we can finish the soldering off on the other side. Step 9 is the fitting of the header for the in-circuit serial programmer, the ICSP. To do this, we have to remove one of the pins of the 6-pin header to make sure that the programmer will fit the right way round. Having done that, we insert that in the printed circuit board and solder it in position like the other components. If we do fit that particular header, we have to fit a wire link on the side of the printed circuit board. Now normally you can use the offcuts from the resistors, but in this particular case it's quite a long wire link, and it's in fact too long even for the bendy jig. So we will have to bend this by means of a pair of pliers. So we bend one end at 90 degrees, insert that in the printed circuit board, and then by eye we move the pliers along to where the hole is, the other hole, bend it down, and we can now put the wire link in, and hopefully it will line up. So now we can turn it over and solder it in position. Step 10 is the fitting of a tantalum capacitor, and we have to be careful to put this in the right way round. The long lead is the positive lead, and you may just about see a plus sign on the capacitor itself. That must be lined up with the plus sign on the printed circuit board. Now we fit the small voltage regulator, which has a black transistor-like body, and we have to splay the legs out a little bit in order to fit it into the wide holes on the printed circuit board. And it must be fitted the right way round, and you can see the flat on the printed circuit board which corresponds to the flat on the voltage regulator. So we fit that and solder that in place. Next we fit the terminal blocks, making sure the wire entries face to the outside of the board. One of the blocks is a 6-way and is obtained by taking the two 3-way and slotting them together using their dovetail slots like that. So then we fit them in the printed circuit board and we solder them in position. Now we fit two electrolytic capacitors. Again, polarity of these capacitors is vital. The negative lead is marked by a silver stripe on the edge of the capacitor body and also by the shorter lead. And the printed circuit board is marked with a plus sign, so the two capacitors must be inserted the right way round. Step 15 is to fit the D connector. You can fit screws to hold it in place if you wish, but they're not supplied with this particular kit. So it's just push it into the holes and turn the board over and solder it. Nearly there. We now fit the large electrolytic capacitor in the board as before. Now we fit the 5-volt voltage regulator, and we have to put this in the right way round with a metal tab facing towards the edge of the board. Having finished the assembly, we now need to do a visual inspection, and this is where the headband magnifier can come in very useful. We need to inspect the bottom of the board, make sure there are no solder bridges, make sure all the components have nice shiny volcanoes, and also that there are no missing components. And I can see on this there are 3 positions where there is a missing component, and in this case I can see that there is a missing component here, which if I read the instructions, it tells me that that component can be fitted later as an option. We're now going through the testing phase following the building instructions. So we set the meter to the resistance range, or we use the continuity beep. You first of all have to make a connection to pin 5 of J6. Now, when you're making a connection to a terminal block, if you simply put the probe on the top, you may not get a reading because that has not made contact with the bottom of the terminal block, which is connected to the printed circuit board. So I've put a wire in there to make sure that we are getting good continuity. So we connect one side of the probe up to the wire, and then the next thing we have to do is to check the outer connection of these pins, which are to be connected to the servos. Next we check against pin 14 of the socket, and these are numbered from the top left going round anti-clockwise. So pin 14 is the last one here, and we do get a continuity beep. And now we need to connect against pin 5 of the D connector. This can be difficult to get the probe in, so I'm going to insert a small piece of wire into the pin, and then I'm going to connect my probe to those 2 wires, and sure enough I get a continuity beep. So that's the first test, which has worked successfully. So we now connect a battery to the terminals here, and we need to check that we're getting 5 volts across the middle pin and the outer pin of the servo connectors. So we set the meter to a range which will show 5 volts, and we check each pin in turn. And ensure that it's 5 volts. We now have to decide how we're going to power the board. There are 2 options. We either provide a link in here, a wire link, in which case the one power supply powers everything, or we can have a different link here and we use a 12-volt supply across 2 positions of the terminal block. We're going to go for the easy option of having everything powered from the one power supply. In the next test, we need to connect again a black wire to pin 5 of the terminal block, set the multimeter to a reading to show 5 volts, and now we need to go to the positive lead of C3. Fortunately, this capacitor has its legs splayed apart to fit the holes in the PCB, and that makes it easy to put the probe on the positive pin, and then we get 5 volts on the display. Now we need to disconnect the power supply and insert the pick. We take the pick out of its protective wrapping, and we'll probably find that the legs are splayed too far apart to fit in the chip holder. So one way of doing this is to get a metal ruler. I simply put my fingers on the end as a form of earth and then gently bend the pins in, each side like this, and then insert it in the holder. If you're doing a lot of work like this, it might be worth getting a device like this where you can simply insert the pick, squeeze the two sides together, and then that provides the perfect setting. And now we can put the pick in the pick holder. Now when we insert the pick, we have to ensure it's at the correct orientation, with a notch in the end of the pick corresponding to the notch on the socket. So we line it up, make sure all the pins are going in the socket positions, gently push it down, and there we are. The board is complete. Now we can try using it. So now we've applied the power through a battery. We've attached a servo, making sure we get the brown lead on the outside. We've connected a wire between 0 and position 1 for the J1 position, and we can test the servo with a servo set box, or we can download a computer program like Servo Set Plus from the MERG website. So with the servo set box, we make sure we're on servo position number 1, we put it in run mode, we can turn the servo into one position, we can then set to the off position and change the servo to another position and save that. Now we can disconnect the servo set box. And then as we connect the wire into the terminal block, the servo moves to the other position. So there we are, the board is now working. All you have to do now is to connect it up to your relevant devices and have fun.